So two truck convoys leave two separate depots at the same time. So there's depot 1, depot 2. Convoy A, so it says convoy A here, is leaving at a rate or at 40 miles per hour. So that's a rate, I hope we all know, because it's miles per hour, it's on time. And convoy B is heading south. So if you look, this guy's going east, this guy's heading south, so he's coming this way, at 30 miles per hour. How fast is the distance between the convoys or the semi-trucks changing? 6 minutes later. Okay, so we need to know that we're going to call this distance from here to wherever the truck is X. And as that truck leaves, isn't that X going to be changing as the truck goes? And we'll call this one Y from here to that truck. And this is changing the whole time because the truck is moving. What is going to be the distance from one truck to the other? What part of the triangle is that going to be? Hypotenuse. So I'm going to call it D for distance. So what this thing is saying is, we want to know how fast is the distance between these two things changing, between these trucks. So what are we looking for? If fast is a rate, what are we looking for? I think you said it right. dd over dt. So the change in d over the change in time is what we want to know. Now, what else do we know? Well, what's dx dt? Does anybody know what dx dt is going to be? The rate this guy's moving? 40 miles per hour. So this is 40 miles per hour. And dy dt, what's he doing? 30. Now, how's he traveling? See, this guy's distance is getting bigger, right? What's this guy's distance from this point getting? Smaller. So what will we do with that 30? We have to make that negative because it's going down. It's getting closer to this point. So because this is getting closer, or that's a negative rate, and since this one's getting farther, that's a positive rate. Is everybody okay with that? Okay, so we know these things. Now, it says at the very beginning, this truck is 15 miles from this point. And at the very beginning, that truck is 12 miles from that point. But we want to know at 6 minutes later. 6 minutes later, we want to know what this distance y is going to be when that truck is right here and this truck is over here 6 minutes later. How can we figure out what that distance is going to be? Anybody know? Okay, well, not quite. We got to use the old formula that distance equals rate times time. Now this one's kind of tough because we want to know how far this truck traveled from this point to this point so we can find this value of y right here. We're looking for that value of y because we need to know. Let me show you this first. How do x, y, and d relate to each other? From geometry, how's x, y, and d relate since that's a right angle? What's that called? Pythagorean theorem. Now we're going to have to use these change of rates. So what do we got to do to this equation to get dx dt and dy dt in there, and to get dd dt, because that's what we're looking for? We got to do a derivative. So we would get 2x, and because we're doing a derivative of x, but it's with respect to t, we must put dx dt on there from implicit differentiation rules. And then this one is going to be 2y, and it will be dy dt. And then this last one is going to be 2d, and it's going to be dd dt. Now we have to have numbers for everything except this, because this is what we're looking for. That's what we need to find. So we got to be able to plug in numbers for all this stuff. So the actual y value we want is 6 minutes after they start. So the actual y value we want is this y value. And the actual X value we want is from here all the way over to there. We want that X value. So we're talking about from here to here we need, and from here to here, and then this is the actual D value we need after 6 minutes. So we got to figure out how far this truck went. It started at 15 miles, and we need to find out how far it traveled in 6 minutes. Well, distance equals rate, and we know this truck is traveling at 30 miles per hour, and we want to know how far that truck traveled in 6 minutes. Now we got a little bit of a problem here. Does anybody know what our problem is? What's this in? What's this in? Minutes. I need to change minutes to hours. Now, I know you guys did this in 5th and 6th grade because my son's in 5th grade and we just worked on this stuff. So I got to change this minutes. I got to change that minutes into hours so I can get miles. Does anybody know how many minutes it takes to get to an hour? How many minutes does it take for an hour? 60 minutes is 1 hour. So we're going to take we're going to take 1 hour over 60 minutes. What's 1 hour over 60 minutes equal? What's that equal to mathematically? That's 1, right? And then we're going to take that times this 6 minutes because we got to change this 6 minutes into hours. So this minutes and this minutes reduce. You with me? This hour will reduce with this hour, so now we've got total miles here. So this is going to be 180 divided by 60 miles, which ends up being 3 miles. So that means this truck from here to here traveled 3 miles. That's 3 miles. He started at 15. So can you tell me what Y equals? If he was at 15 and he came 3 miles? So Y is 12. You follow where all that came from? That's pretty tough. Now we got to figure out how far this is from here to here. This truck is going 40 miles per hour. So again, distance, we're going to use distance equals rate times time. So we're looking for the distance. This truck is traveling 40 miles per hour. Maybe I should put miles over hours again so we can reduce them. And it's going for 6 minutes again. But we need to change this into hours. So I got 60 minutes down here to get these out and 1 hour in the top because I got to get rid of the hours because I need distance. So this hour and this hour reduces. So this is going to be 240 miles divided by 60. So let's see, those reduce. So this truck will have traveled 4 miles. So he started at 12 and he went 4 miles. So what's X equal then? 16 miles. Do you see where those come from? Now I got to find out what D is too, because there's a D in here I got to plug in for. So we're talking at the exact moment that this is 12 and that this is 16. We got to find D. So we got to use this top one for that. So we use that top one and we're going to get 16 squared plus 12 squared is going to equal D squared. So I believe 16 times 16 is 256, and 12 times 12 is 144. So I believe we get 400 here, and if you square root 400, I believe you get 20. So that means at the exact time that X is 16 and Y is 12, D is 20 miles. So now I've got all the numbers I need to plug in here. Now something I would probably do to save myself some time, do you guys see both sides have a common factor of 2? So to save my math, use smaller numbers, I would start by dividing each side by 2. So that's going to get rid of all these 2's in front. And this works every time you do this with Pythagorean theorem. So I'm going to plug X in, which is 16. dx dt is 40. You know what? I'm going to put the, let me put the stuff in here. So this is 16 miles This is 40 miles per hour. And then plus y is 20 miles. And dy dt is negative 30 miles per hour. Oops, let me put miles over hours. And then I'm going to erase this so we can see it better. And then I got d that I got to stick in there, and d is right there, 20 miles. And then this is d dt. Anybody got a question so far? Yeah.
Did you put 20 miles for the second one?
Maybe. Did I screw up?
I thought it was 12.
Okay, this should have been 12. Thank you. Yeah, this was y. My fault. It's at 12. Maybe I should have put them up here. X was 16 miles. Y was 12 miles. And d was 20 miles from Pythagorean theorem. All right, so when I multiply these two together, I'm going to get, let's see, 0, 4 times 6 is 2, carry 2, 640. This would be miles squared per hour. Plus, this will actually be minus because it's going to be negative 360 miles squared per hour. And over here, we still got 20 miles. dt. So then I'd go ahead and subtract those two. So 640 minus 360 is what, 280? We got 280 miles squared per hour equals 20 miles dt. So you're going to divide by 20 miles. Or you're multiplying by 1/20th miles. So I hope we see that that gives me d dt, which is what I'm trying to find. This miles will reduce with one of these miles. So do you see I'm going to have miles per hour still? So 280 divided by 20 would be 140 miles per hour. So the rate that the dt is changing is a rate of 140 miles per hour at t equals 6 minutes from when they started. Yes. Did I divide wrong? It is 4. No. Yeah, it is 14. My bad. I can't divide either. So it is the rate that dt is changing is 14 miles per hour. Thank you, ma'am. Good dividing right there. So that's pretty tough stuff. And it takes forever. Do you have any others you want to see? Yeah?
You just did 19 as well.
All right, we're going to do 19 as well, and then we're probably going to call it a day. Now this says calculators, so you better get your calculators out. 2 commercial jets are 40,000 feet, at 40,000 feet, are both flying towards an airport. Plane A is flying at 520 miles per hour. So we got to call one of these, and it's 100 miles from the airport. While plane B is flying 450, it's 240. This looks further, so I'm going to call this B, and I'm going to call this A, okay? Because it looks closer in the picture. So it says that dA dt, the rate of plane A, the one that's 100 miles from the airport, is 520. Now, if I were doing this, I'd put negative because it's going closer. It's decreasing miles per hour. It's decreasing distance. And dB dt is also decreasing distance because it's flying left closer to this, and it's going at negative 450 miles per hour. And right now at this time, this plane B is 240 miles out there, and this plane A is 100 miles away from the airport. Now this 40,000 feet doesn't mean anything except that it's just that they're in the same plane, so it's it's going to be a perfect right triangle here. All right, so how fast is the distance between the two planes changing at this time? So again, we are looking for DD. DT is what we want to know. So we also need to find D. So this is, I guess we'll call this B. We'll say B is 240 miles out. A is this. We'll call this C for Pythagorean theorem. So we are looking for DC dt. So this is very similar, except it's a little easier because we're not talking 6 minutes later. We don't have to do any of that messing with the time because we're talking right at this instant. So we need to first of all know that A squared plus B squared equals C squared. And when you square or do the derivative, you get 2A dA dt. And if you want to use X and Y and D, you can. It does not make any difference what variables you use. I'm just going along with what's in the problem because it helps me to keep it simpler. And again, you see both sides are divisible by 2, so I would get rid of these 2's by dividing everything by 2 first. You do not have to. You can divide later. And now I got to plug these numbers in. So I know A is 100, and I know dA dt is negative 520. I guess I'm not going to put these in here, but they work the same way as the other one did. And then B is 240, and dB dt is negative 450. C we don't know, and we're looking for dC dt. How am I going to find C right at the moment this is 100 and 240? The same thing we did last time. We're going to do Pythagorean theorem. Somebody take your calculator and tell me what C is. 250 exactly?
No, 260.
260. So then we're going to stick 260 in for that. Okay? So now it's just a matter of algebra 1. Do you need me to finish? And again, this is going to be dC dt is going to be in miles per hour. And it's going to be a negative number because their distance is decreasing from each other. They're both coming towards this thing, and this distance is decreasing the whole time. Do you need me to finish this, or can you get somebody got a calculator and got an answer?
I got negative 615.385.
So the distance between the airplanes is decreasing, or you would say changing at a rate of negative 615.385 miles per hour. When plane A is 100 miles from the airport and plane B is 240 miles from the airport. So that one's a little easier. All right, so you got a whole bunch more of those to practice. I already put the key on Canvas. So you can go by and look at that key.